Hello students, all of you are welcome to my YouTube channel Netcam Guru, and in today's video I'm going to describe about another topic of ionic equilibrium, class 12 chapter 2. And today I'm going to describe about autoionization of water and pH scale. So last time in previous video I have discussed about the Ostwald dilution law and its related numericals. So today I'm going to describe about autoionization of water. So let us see what is autoionization of water. Students, you might think that water is a very weak electrolyte, and how does it ionize? But water ionizes in very small extent itself. Ionization of water itself in very small extent and attaining equilibrium at a constant temperature is called autoionization of water. So water ionizes. So water ionizes in a small extent itself. Water ionizes in a small extent itself to attain equilibrium. At constant temperature. Is called autoionization of water. So water is a weak electrolyte, but water also ionizes in very small extent, and itself attains the equilibrium conditions with unionized water. And this kind of process where itself water ionizes is called autoionization of water. So water also ionizes itself. You can relate it like water. When it ionizes, it gives H plus and OH minus. Similarly, when H plus and OH minus combines, it gives water. So it attains equilibrium after some times. So this kind of process is called autoionization of water. So here you can write water as a liquid and H plus as aqueous ionic form, and this is also in aqueous form. This H plus can be also written as hydronium ion. So H plus is equivalent to hydronium ion. You can write for concentration of H plus, you can write concentration of hydronium ion. So in this way, water itself ionizes into H plus and OH minus in very small extent. That is called autoionization of water. Students, water itself ionizes in a small extent, and ionized water, that is H plus and OH minus, attains equilibrium with unionized water, and in this way equilibrium is attained. So this is called autoionization of water. And autoionization of water indicates that it is in equilibrium, and when the process is in equilibrium, then applying the law of mass action, what can we write? Law of mass action is equals to KEQ, equilibrium constant, equals to product of concentration of products divided by reactant, concentration of reactant. And water ionizes in very small extent. So ionization of water is very small extent. So concentration of water can be taken as constant, because water concentration of water does not decrease as it ionizes in very small extent. So concentration of water can be taken as constant. So when you take equilibrium constant and another constant, concentration of water, then KEQ multiplied by concentration of water equals to H plus multiplied by hydroxide. You can write like this way. So these two concentration, product of these two concentration, equilibrium constant and concentration of water, which is also taken as constant, can be written as KW. KW is ionic product of water. Are also called as ionization constant of water. Whatever you say, that we call it as KW. Therefore, what is KW? You can see from here. Therefore, KW is equals to concentration of H plus multiplied by concentration of hydroxide. So This is the final expression which gives you idea about autoionization of water. So let's say equation number 1. So you can easily find out Kw. Kw is ionic product of water, or ionization constant of water, that is equals to product of S plus ion concentration multiplied by product of S plus concentration and hydroxide concentration. Okay. When you are asked about autoionization of water, then you have to derive the expression like this. So Kw is ionization constant for water, or ionic product of water. And one more important thing is Kw is always constant for a given temperature. Ionic product depends upon temperature. At constant temperature, it is always constant. So value of Kw depends on temperature. Because if you increase the temperature, then the value of Kw will increase. The Kw value, or ionic product of water value, depends upon temperature. So how do you define ionic product of water? So you can easily define the ionic product of water now. Ionic product of water is defined as the product of concentration of H plus and hydroxide at constant temperature. When water ionizes itself, and attains equilibrium. So whenever water ionizes itself and attains equilibrium, at that time, what is the product of concentration of H plus and OH minus? This is called ionic product of water. So you can easily define the ionic product of water. Ionic product of water has got its constant value according to given temperature. And what is the ionic product value of water? Kw value at 25 degrees centigrade is equals to 1 multiplied by 10 to the power minus 14. This is the ionic product of water at 25 degrees centigrade, but this value depends upon temperature. So as you change the temperature, then Kw value will be changed. But at constant, at 25 degrees centigrade, this is 1 into 10 to the power minus 14. So this is about ionic product of water. Now, what is the significance of Kw? Significance of Kw. What is the importance of Kw? So let us discuss about significance of Kw now. Significance of Kw, ionic product of water. First significance is for any aqueous solution. For any aqueous solution, of acid, base, or salt, the product of H plus and hydroxide is always constant at 25 degrees centigrade. That is equals to 1 into 10 to the power minus 14. So whatever be the solution, okay, whether the solution is aqueous solution is of acid, base, or salt, the product of H plus ion and hydroxide ion is always constant. That is equals to 1 into 10 to the power minus 14. This is the first significance, because whether you prepare the solution of aqueous solution of acid, base, or salt, no problem that the product of H plus ion and hydroxide ion concentration, which is equals to 1 into 10 to the power minus 14. So this is first significance of this Kw, okay. And for pure water, or neutral solution, S plus is always equal to S plus ion concentration is always equals to hydroxide ion concentration, okay, for water, and for pure water and for neutral solution, that is surely equals to 1 into 10 to the power minus 7 at 25 degrees centigrade. Okay, for neutral solution, you can easily say that S plus ion concentration is equals to hydroxide ion concentration, which is equals to 1 into 10 to the power minus 7 at 25 degrees centigrade. And for acid solution, for acid solution you can easily write the S plus is greater than S plus ion concentration is greater than hydroxide ion concentration. So S plus is always greater than 10 to the power minus 7. As S plus increases, then hydroxide decreases, such that the important thing what you have to know that such that S plus multiplied by hydroxide must be always constant 10 to the power minus 14. It must be always 10 to the power minus 14. So as S plus increases, hydroxide decreases, or if S plus decreases, then hydroxide increases, because 10 to the power minus 14 must be constant always at 25 degrees centigrade. You should not forget that this all data is in 25 degree centigrade. As you change the temperature, then the value will be changed. Similarly, for basic solution, what happens? You can easily guess it. For basic solution, okay, for basic solution you can easily write that S plus ion concentration is smaller than hydroxide ion concentration. That is, S plus is always smaller than 10 to the power minus 7, such that that always maintains S plus multiplied by hydroxide will be equals to 1 into 10 to the power minus 14 at 25 degrees centigrade. So whether S plus increases or hydroxide increases, the total product must be remain constant, that is equals to 1 into 10 to the power minus 14 in any solution. At any aqueous solution, what can we understand from this discussion is that for any aqueous solution, S plus ranges from 10 to the power 0 to 10 to the power minus 14. Such that in such a way that S plus product of S plus and hydroxide will be equals to 1 into 10 to the power minus 14. So I say that if S plus ion is 10 to the power minus 1, then hydroxide must be equals to 10 to the power minus 13. So that product must be equals to 1 into 10 to the power minus 14 at 25 degrees centigrade. So students, what you must know here is that for any aqueous solution, the product of S plus and hydroxide ion concentration is always remaining constant at a particular temperature. If you are talking about 25 degrees centigrade, then there will be S plus and hydroxide ion concentration product is always equals to 1 into 10 to the power minus 14, which is called ionic product of water. So students, this is about autoionization of water. So in case of autoionization of water, what you must know is water ionizes itself into a small extent, that is it ionizes into S plus and hydroxide ion and attains equilibrium, so that it follows the law of mass action, and you can easily find out the ionic product of water. Ionic product of water is equals to S plus and hydroxide ion in the ionic equilibrium state when water ionizes itself, which is equals to 1 into 10 to the power minus 14 at 25 degrees centigrade. So this is the concept of autoionization of water. Okay. So student, I think you understood about the autoionization of water. Now what is the effect of temperature in Kw? Effect of temperature in Kw. The ionic product of water is affected by the temperature. Autoionization of water is is endothermic. What does it mean, endothermic? Endothermic means what? It needs heat for the process. Okay, it absorbs heat for the process. So it means that when temperature is increased, then when temperature is increased, then Kw value, the ionic product value, increases, because more number of ions will be formed, because it is the process endothermic, and if you supply the heat, then it ionizes more, and the product will be ionic product of water will be more. For example, at 25 degrees centigrade, if you talk about Kw, then I have already told you that it is 10 to the power minus 14. Similarly, at 65 degrees centigrade, if you talk about, then Kw value will definitely increases, and it will be equals to 1 into 10 to the power minus 13. So did you know that when you increase the temperature, then Kw value is also increased? Uh, s- so though the value of Kw will increase, one more thing is, though the value of Kw increases, though the value of Kw increases with temperature, one important thing you must know, that though the value of Kw increases with temperature, but S plus is always equal to hydroxide in pure water. If you talk about pure water, that will be always equal. S plus and hydroxide ion will be always equal. That means at 65 degrees centigrade, if you talk about S plus ion, that is 1 into 10 to the power minus 13 divided by 2, so just half. Okay, whatever be the Kw value, but that will be, there will be S plus and hydroxide ion will be equal in pure water. For example, at 25 degrees centigrade, we have already told you that S plus ion concentration and hydroxide ion concentration are 10 to the power minus 7 in pure water. Similarly, at 65 degrees centigrade, that is 1 into 10 to the power minus 13 divided by 2, S plus ion concentration is, and hydroxide ion concentration, both are similar. So whether temperature affect the Kw or not, but S plus ion and hydroxide for pure water will not be changed. That is, for pure water always S plus ion and hydroxide ion will be always equal. But what is the value of S plus ion concentration of pure water at 65 degrees centigrade? Is it 10 to the power minus 7? Surely not. It is 10 to the power minus 13 divided by 2. That is, I think, 1 into 10 to the power minus 6.5. Okay, that will be changed. But the temperature surely changes the product, ionic product value, but the S plus ion and hydroxide remains constant, equal in pure water. For example, if you talk at 0 degree centigrade, at 0 degree centigrade, Kw is nearly equal to 10 to the power minus 15. Okay, that is less, because if you decrease the temperature, then Kw value decreases. 10 to the power minus 15, that is S plus ion is equals to hydroxide, in this case equals to 1 into 10 to the power 7.5 molar. So did you know that here both are equal, but that is not 1 into 10 to the power 7, 10 to the power minus 7, it is equals to 1 into 10 to the power minus 7.5. So at 0 degree centigrade, the S plus ion is a little bit less, 1 into 10 to the power minus 7.5, but at 25 degrees centigrade, 1 into 10 to the power minus 7, and at 65 degrees centigrade, 1 into 10 to the power minus 6.5. So though the value of S plus and hydroxide ion will be changed, but for pure water, S plus and hydroxide will be always equal. Okay, that you must know. So this is the effect of temperature on Kw. So friends, in today's video, I have described about the autoionization of water and significance of Kw, significance of ionic product of water, and what is the effect of temperature on ionic product of water. These three things I have talked about it. So I think surely you knew about it. Okay. Hope that you knew about these all things. So now in next concept, I'll be discussing about the pH and pH scale. So when you know about the autoionization of water, you must know about the pH and pH scale. So let us discuss here about pH and pH scale. So generally in aqueous solution, generally in aqueous solution, S plus is very small. S plus is very small. S plus amount is very small, and in order to express S plus, S plus and concentration in convenient way, in easy way, Sorensen is the name of scientist. Sorensen introduced the concept of introduced the concept of pH. Generally, in aqueous solution, As plus ion concentration will be very less, and its value, to measure its value is difficult. So, how to express the hydrogen ion concentration, that is solved by the Sorensen, the scientist Sorensen. And Sorensen introduced the term pH, a concept of pH and pH scale. He introduced the term pH and pH scale. So, what is pH? Now, let us define pH. Okay, what is pH? pH can be defined as, pH is negative logarithm of S plus ion concentration, negative logarithm of S plus ion concentration in moles per liter or molarity. This is pH. pH is equals to negative logarithm of hydrogen ion in moles per liter or molarity. So you can write pH equals to minus log 10 to the power minus log S plus ion concentration, but that S plus ion concentration must be in molarity. Okay, so when you express the hydrogen ion concentration in molarity, moles per liter, then you just find out minus log of S plus ion concentration, that you get pH. So pH is a unit. pH is a term, quantity that expresses the hydrogen ion concentration, and that is expressed by negative logarithm of hydrogen ion concentration, and hydrogen ion concentration must be in moles per liter. So to find pH, first of all find out the hydrogen ion concentration in moles per liter or molarity, and then you find out the minus log S plus, you calculate it and you get pH. Okay, in this way you can find out the pH of any solution. So I think you knew about the pH. So pH is negative log of hydrogen ion concentration, which is expressed in molarity. This is the formula. Okay. Also you can write pH equals to minus log, sometimes instead of hydrogen, hydronium ion also you can write. So for neutral solution, for neutral solution pH equals to always 7, and for acidic solution, for acidic solution, pH is always less than 7, and for basic solution, pH is always greater than 7. But these all at 25 degrees centigrade. Okay, and these all are mentioned in 25 degrees centigrade. So what is the normal range of pH? The normal range of pH at 25 degrees centigrade equals to 0 to 14. And this is at 25 degrees centigrade. This is 0 to 14 is the range of pH for the solution. So the pH can be expressed from 0 to 14. Okay, if 7 less than 7, then that will be called acidic, and if more than 7 to 14, then that is called basic, while 7 is neutral. So in this way we can express the concentration of hydrogen ion in terms of pH. So pH is negative log of hydrogen ion concentration, that you can easily use the formula and you can calculate. But one more thing is, you must know that for concentrated solution, for concentrated acidic solution, if you have concentrated acidic solution, then you get pH in negative form. So for concentrated alkali, if you have concentrated alkali, then you get pH greater than 14, you get pH more than 14. So for such solution, pH is not useful term to express hydrogen ion concentration. So this is the limitation of pH concept. Okay, limitation. What is the limitation of pH concept? pH is only measured for dilute solution, where acidic solution, basic solution, or neutral solution is not highly concentrated. But for highly concentrated solution, pH will be out of range. For concentrated acid solution, if you find out, then it will be less than 0, that is negative. And for concentrated alkali, if you find out the pH, then that will be greater than 14. So for concentrated solution, the pH concept is not working. So this is the limitation of the concept of pH. So pH is always useful for the dilute solution. Generally, we have dilute solution. We use the dilute solution in daily life. So pH is very useful. Now I mentioned some of the pH value of some fluids. So black coffee. Have you ever taken black coffee? Black coffee has pH. How much pH? Can you guess it? It is acidic, and that is 5.0. So whenever you take black coffee, then you feel you will have more acidic liquid. So it increases acidity in our body. Black coffee has got pH 5.0. So egg white, what is the pH of egg white? Can you guess it? Egg white pH is 7.8 and it is alkaline. Rainwater. Rainwater is definitely acidic because acid rain you might have heard about the acids in the environment, and when acidic oxide combines with the water it forms acid, and rainwater will be surely acidic, and that will be generally 5.7. Rainwater is lemon juice. Lemon juice is definitely acid, so it will have pH 2.2. And what is about apple juice? Apple juice, have you ever taken apple juice? Apple juice has got 3.1 pH, and milk has got also acidic pH, that is 6.6. Similarly, what is the pH of human blood? Human blood has definitely constant pH, that is 7.4. It is slightly alkaline. And human urine may have a range of pH, that is 5.5 to 7.0, but it must be in acidic range. It should not be alkaline. Let's say saliva. Human saliva have got the pH range 5.5 to 6.4. Similarly, tears, human tear, asu, or what we call tear, that tear has got 7.4 pH. So these are the common fluids pH. You easily guess that how useful is the concept of pH to measure it. For example, if human blood has got acidic pH, then you might be suffered from some disease, or there is a physiological change. So you must know the basic concept of pH of human fluids as well as some foods. So the concept of pH is very important for foods and our body fluid to maintain the normal function of our body. So I hope that you got some concept about the pH of some fluids, some basic fluids. Now I'm going to next topic of pH, that is relationship between pH and pOH. So what is the relationship between pH and pOH? So let us discuss about relationship of pH and pOH. So I have already told you that pH is minus log of hydrogen ion concentration, and similarly pOH will be equals to minus log of hydroxide ion concentration. And pKW, you can also say that pKW equals to minus log KW. So easily you can define pH, pOH and pKW. These are the formula for defining pH, pOH and pKW. So what is the relationship between pH and pOH? So we can easily derive it. From autoionization of water, from ionic product of water we can say, or autoionization of water, from ionic product of water we can easily write H plus multiplied by hydroxide equals to KW, right? This I have already told in autoionization of water. So this is one of the equation. Now this equation can be used to derive the relationship between pH and pOH. Now taking negative log on both sides. So let us take negative log on both sides. So how do we take negative log in both sides? If we take negative log on both sides in this equation, then what do you get it? Let us see. Negative log of S plus multiplied by hydroxide equals to negative log of KW, right? So this is log AB. The formula of log AB is log A plus log B. So minus log S plus ion concentration plus log hydroxide ion concentration. This is the formula of log AB equals to minus log KW, and you can easily open it. Okay, minus log S plus ion concentration minus log hydroxide ion concentration equals to minus log KW. You can write minus here and you can put into bracket, it just same it. So what do you get it? Let us see. Minus log H plus ion is equals to pH plus minus log hydroxide ion is POH, and you know this is pKW, right? So at 25 degrees centigrade, you know, I have already told you that at 25 degrees centigrade pKW value is 14, because kW is equals to 10 to the power minus 14 at 25 degrees centigrade, and minus log kW equals to 14. So we can easily write PS plus POH equals to 14 here at 25 degrees centigrade, but this value may be changed as you change the temperature. So this is equation number 2, and this is final expression of relationship between pH and POH. So if you get pH value, you know, you can easily calculate POH by subtracting from 14. So if you know pH, then you can easily get pH by subtracting with 14. So this is a very important relationship for numerical problems to solve it. Once you get pH value, you can easily get POH, and if you get POH, then you can easily get pH by using this expression. So this is the relationship between pH and POH. Okay. Now, what are the applications of pH? You know, you might have heard about cosmetic applications. Many chemicals are using as cosmetics, which are applying in on your skin. So for the cosmetic, you know, the pH value of the product must be constant, and it should be maintained, or it should be judged, or it should be checked. And similarly, you know, for many foods, the pH value must be maintained constant. So for biological perspective and for cosmetic perspective, the pH value is very important to maintain in our body. For example, you might have heard about the buffer, you know. Our blood has got a buffer system. What is the buffer? You know, I'll be talking in next video about buffer. But you know, our body, inside our body, a system is maintained, which is called buffer. You know, when we have a little amount of acid or base, the pH of blood will be always constant due to buffer. So blood fluids, body fluids have got constant pH due to buffer, that will not increase or decrease when you have acid or base as a food. So buffer is very important. So next time, in next videos, we will be discussing about the buffer also. So how do you measure the pH? How to measure the pH? pH. How to measure pH? We will have many ideas. So pH paper can be used to measure pH of the solution. Similarly, pH meter also can be used. pH meter can be used as advanced from its digital pH meter can be used nowadays. And similarly, universal indicator also one of the idea to measure pH of the solution. So these three ideas that can be used to measure the pH of solution. So you know, analytical chemists often have to measure the pH of the solution, and that's pH of the solution must be maintained. So for that, you know, pH must be measured, and analytical chemists generally measure the pH by using pH paper, pH meter, and universal indicator. Now we talk about pH scale, pH scale and temperature. What is the relationship between pH scale and temperature? So pH scale and temperature. Let us talk about it. pH scale and temperature. Is there any relationship between pH scale and temperature? So let us see. At 25 degrees centigrade, you know, at 25 degrees centigrade, Kw is equals to 10 to the power minus 14. So what is the pH range at that time? pH range equals to 0 to 14, right? So neutral pH is how much at that time? Neutral pH equals to 7. This is at 25 degrees centigrade, right? But at 65 degrees centigrade, let us say 65 degrees centigrade, Kw is pH range. Kw is equals to 10 to the power minus 13, and pH range will be at that time 0 to 13, you know. And neutral solution has got neutral pH at that time equals to 6.5. So at 65 degrees centigrade, you know, what is the pH of neutral solution is 6.5. It is not 7, right? At 25 degrees centigrade, this is 7. pH of neutral solution is 7. But at 65 degrees centigrade, you know, pH of neutral solution is 6.5. That you must know. And at 0 degree centigrade, at 0 degree centigrade, pH range will be equals to 0 to 15, as Kw will be equals to 10 to the power minus 15 at 0 degree centigrade. As temperature is decreased, the value of Kw is also decreased, and the pH range will be different. At that time, neutral solution will be, neutral solution has got pH equals to 7.5. So, uh, student, you should not understand like this way, that pH of neutral solution is always 7. That is not. That is at 25 degrees centigrade, but at 0 degree centigrade and at 65 degrees centigrade, the pH of neutral solution is different. At 65 degrees centigrade, pH of neutral solution is 6.5, and at 0 degree centigrade, pH of neutral solution is 7.5. Okay. In this way, you can easily understand that our pH scale, in this way, pH, what we can understand that pH decreases with increase in temperature. So this is our conclusion, right? pH decreases with increase in temperature, because at 65 degrees centigrade, neutral is 6.5, at 0 degrees centigrade is 7.5. That is, when temperature is decreased, then pH value will increase. So pH decreases with increase in temperature. That is, when temperature is increased, that pH value decreases. So this is the relationship between pH scale or pH with temperature. So let us talk about our body temperature. Okay, our body temperature. What is the body temperature? Normal body temperature, that is 37 degrees centigrade. Normal body temperature. What is the normal body temperature? Human body temperature, that is 37 degrees centigrade. This is around 37 degrees centigrade. So pH of, at that time, pH of neutral solution, pH of neutral solution will be not 7, but it will be equals to 6.8, and the pH range will be 0 to 13.6. Okay, this is pH range in our body. So whenever we have normal body temperature, at that time, the pH of neutral solution will be 6.8 and pH range will be 0 to 13.6. When temperature is increase or decrease in our body, then pH pH range will be changing. So pH is sensitive with temperature, that you must know. Okay. Finally, let us discuss about limitation of pH scale. What are the limitations of pH scale? Is there any limitations of pH scale? Does it have any limitations? Surely, because everything has got its limitation. This pH scale is only for aqueous solution, not for non-aqueous solution. For example, if you have prepared the solution in ammonia or solution in sulfur dioxide or any other non-aqueous solvent, at that time the concept of pH will not be working. So this concept is only for aqueous solution and not for non-aqueous solution. This is the limitation, and this is limited by the temperature. Whenever you measure the pH, at that time you must mention the temperature, because at particular temperature the pH value will be changing, and if you say pH of certain thing is this much, then you must mention that at what temperature this pH is. So the concept of pH scale is limited by the temperature. Similarly, the scale is not working for concentrated acid and base, only for dilute solution. Okay, so concept of pH is only working for dilute solution and not for concentrated solution, that you must know. So these three things are the limitations of pH scale. So pH scale has got some limitation. That three things you must know while you read about the pH. So friends, today I am discussing about pH scale, pH, and autoionization of water. For example, what is the effect of temperature on pH, right? What is our body temperature, pH, and pH range? So hope that students, all of you knew some new concept about the pH and pH scale. And this is very important concept in class 12 chemistry, class 12 physical chemistry in chapter 2 ionic equilibrium. So today I have discussed about two concepts in summary: autoionization of water and pH scale. uh, hope that you have learned much more, and next time we will be solving about some numerical problems related to pH. So until and unless you knew about this concept, you cannot solve the numerical problem. So first of all, get the concept. So students, till date, if you have not subscribed my channel Napkin Guru, then you subscribe this channel, and you will get notification about the new videos, and you will be preparing new concept in the class 12 chemistry. So let's share and comment some confusion. If you have, then let's do comment on the comment box. Goodbye for today.